All right, here we go. Let's take a look at these problems in case you have problems with them. I'm going to walk through them. Okay, I'm just going to read it because I haven't read it yet. It takes a lot of supplies to keep the International Space Station going. On February 21st, NASA asked commercial launch services such as SpaceX to figure out what they would charge to deliver cargo to the station. NASA plans to buy this service between $1 billion and $1.4 billion each year from 2017 to 2024. Groups did the math to figure out how many launches would be needed to deliver the required materials to the station. On the return flight, trash such as discarded equipment and garbage will be brought back home. For each year, NASA will need up to 16,750 kilograms, of pressurized cargo delivery to the station. This amount of cargo will fill about 30 lockers. Another 4,000 kilograms of unpressurized cargo will be included in each launch. This amount of cargo will fill about 8 lockers. There will be 5 flights per year. Let's figure this out. What is the total mass of pressurized and unpressurized cargo? Let me open this up real quick so I can see this numbers. What is the total number of pressurized and unpressurized cargo per year and per flight? So per year, they were giving us the amounts. So per year, they're giving us 16,750 kilograms of pressurized and another 4,000 of unpressurized. So that should be 20,750 kilograms, per year. All right. And then again, this is the number that you're going to type into the box and it should turn green and let you know if it's right. No comma though. Don't put a comma or anything else. And then per flight, right? If it says there's 5 flights per year, and it's 2,750 kilograms per year. So if you really, you could probably just figure out to divide it by 5, but if you really want to set it up correctly, you'd say 2,750 kilograms in 1 year. Set it up like this. And there are 5, and then there are 5 flights in 1 year. See, the years have to go like that, so they cancel. So see, basically you're just dividing it by 5, right? But if you want to be fancy with the units, then please feel free. 20,755. So that's 4,150 kilograms per flight. And again, you're going to type that 4150 in the box. All right. So here, right, to type this in the box and then type 4150 in the box. No commas. All right. For each flight, 800 kilograms of fresh drinking water will be delivered to the station. If 1 gallon of water has a mass of 3.8 kilograms, how many gallons could be transported every year? So there's 1 gallon is 3.8 kilograms, right? So there's my conversion, and I'm starting with 800 kilograms as my given. So 800 kilograms is my given, and I know there's 3.8 kilograms in 1 gallon. All right, and you know to put the kilogram on the bottom so that it cancels out with the top. So then 800 divided by 3.8 is going to be 210 to the nearest gallon. So that's going to actually be 211. So here again, you're going to put this in the box. I better check that out. Is that what they put? Oh, whoops, that wasn't the whole answer yet. That was 211 gallons. Oh, that's per flight, right? Oops. And let me leave it like this then. So I'm just going to leave it as 210.5 for now. 210.5 gallons. But that's per flight, right? But it wants to know how many per year, right? So remember, there were 5 flights. So 210.5 gallons, times 5 flights. Times 5. It's going to be 1053 when you round it. Yeah, that's fine. 1053 gallons. So this is right. This was gallons per flight and then flights per year, right? That's why we're multiplying by 5. So in this box, right, you're going to write 1053. All right. Each pressurized locker requires a continuous power of 120 watts at 28 volts. Oh, good. We're doing circuits next. Each unpressurized locker requires a continuous power of 250 watts at 28 volts. What is the total watts used by both the pressurized and unpressurized locker for each flight? All right. So we had, there were 30 30 each year, okay, right? So did they give it by year, I think, right, when we started? Yeah, per year. Okay, so let's do it all per year first, and then we'll figure it out, okay? So I know that there were going to be 30, so for the powered ones, right, there were 30, right? 30 lockers, yeah, the pressurized, not powered, pressurized. Okay, so the pressurized, there were 30 lockers per year. Okay, and each locker, so one locker, takes 120 watts. That'll be a capital W. Okay, so that's going to be 3,600 watts per year for the pressurized. Okay, and then the unpressurized, I think there was only, what, 5 lockers? 8 lockers? I'm looking at this other one. 8 lockers. 8 unpressurized lockers per year. Okay, oops, I should have been going like this. I'm trying to do this new method. Sorry, I'm going to confuse you now. Okay, and then one locker here, these require 250 watts of power. Okay, my unpressurized is more, but okay, fine. Okay, so 8 lockers times 250 is going to be 2,000 watts per year. Okay, so my total, I'm looking at 38 plus, oh, I can't add, 5,600 watts. Okay, right? So that's the total, but that's for the whole year, right? So that was 5,600 watts per year. And then remember, there were 5 flights per year. That's why you're dividing that. Okay, so 5,600 divided by 5 is 1,120 watts per flight. Okay, and then that's what you're going to put in the box, your number there. Okay? All right, good. And then number 4, if it costs $4,500 per kilogram to place items in orbit, what is the cost for each launch? Okay, right? So for each launch, that's per flight. So back here in number 1, right, we already figured out how many kilograms there were, okay, in each launch. Okay, so there were 4,150 kilograms in each launch. Okay, and then they're telling us that it costs $4,500 for every 1 kilogram. Okay, to pace it. If I cancel that, wow, that's expensive. 4,500 times 4,150. That is going to be a very large number. Woo. Round to the nearest dollar, I guess. $18,675,000. That's very expensive. That's $18 million. But again, when you put it over here, don't put the commas, okay, or else it won't show up right. Okay, beautiful. Check.